In this lesson, we're going to look at writing numbers in scientific notation. All right, so numbers in scientific notation are made up of three parts. So there are three parts. You have a coefficient, you have a base, and you have an exponent. So here's an example of a number that's written in scientific notation. So we have 5.6 times 10 to the, let's say, fourth power. All right, so this number is a number that is written in scientific notation. Now, what makes this a number written in scientific notation is this. So you have the coefficient, and the thing about the coefficient is this. So the coefficient must be written, so must be a number that is between 1 and 10. So basically it's less than 10 and greater than 1. So notice one thing that you need to always look for is this. So there's only one non-zero digit. So either 1, 2, 3, 4, 5, 6, 7, 8, 9 that's in front of the decimal point. So you can have several digits. You can have more than one digit behind the decimal point, but you can only have one non-zero digit in front. So this cannot be a zero, but it can be any one-digit number that's between 1 and 9, that is at least 9 and less than 10, so meaning 9, at most 9. So another example would be something like this, where you have, let's say, 7.2865 times 10 to the negative 7th power. So notice that in this scientific notation, this number that's written in scientific notation, there's only one digit, non-zero digit, in front of the decimal point. But again, you can have more than one in back of the decimal point. Okay? So the coefficient, so these are your coefficients here. So that's a coefficient. So the coefficient must be a number that is between 1 and 10. And notice 5.6 is between 1 and 10. 7.2865 is between 1 and 10. Okay? The base is 10. So notice both of those bases are 10. And the exponent is an integer. Okay, the exponent is an integer. So remember, an integer is like 0, 1, 2, 3, and so on. -1, -2, -3, and so on. Okay? All right, so notice 4 is an integer, -7 is an integer. All right? All right, so let's look at some examples. So the first example will be this. So make sure you understand what a number written in scientific notation looks like. All right, so let's look at the first example. Okay, so part 1 says this, write each number that's written in scientific notation. You want to put this number in standard form. So let's see what that means. So here's the first one. So number 1, we have 3.6 times 10 to the third power. So notice we do have a number that's written in scientific notation, and I want to write this number in standard form. So standard form just implies for you to write this as a regular number, so to speak. So in other words, to rewrite this without 10 to the third power. All right, so that's what that means. So one way to look at this is this way. So you have to look at the exponent of the base 10. So the power of 10. So you're looking at really powers of 10 here. So the exponent is a positive 3. All right, so since the exponent is a positive 3, then this number here, this number that's written in scientific notation, has to be greater than 3.6. So that means that I've got to move my decimal point some places to the right, because this number that has a positive exponent has to be bigger than 3.6. So multiplying by 10 to the third makes 3.6, makes this coefficient, makes this this number bigger than this coefficient. Okay? So basically all you got to remember to do is this, is since this exponent is a positive 3, then that means I'm going to take 3.6, I'm going to take the decimal point, and I'm going to move it 3 places to the right. So 1, 2, and then 3. So in those little, let's say this little curve here, I'm going to put zeros. And so therefore 3.6 times 10 to the third is 3600. So it's equal to 3,600. So this is what I mean in standard form. So just basically writing this numbers in scientific notation to a number that you've dealt with for the most part, okay, in your studies in math. All right, so the other way I want you to think about this is this way. So we know that 10 to the third is 1 and 3 zeros, right? So that's going to be 1,000. So basically what you're doing is you're taking 3.6 and you multiply it by 1,000. And so since I'm multiplying by 1,000, that means that the decimal point has to be moved 3 digits. So 1, 2, 3, or 3 places. See those 3 zeros? To the right. So that becomes 1, 2, 3. So that's going to equal 3,600. Okay? All right, so remember what we just talked about. So the way we talked about this here was this. Since the exponent, okay, so the exponent, I'm going to go ahead and write it out. The exponent 3 is positive. The exponent 3 is positive. So this number that's written in scientific notation, so 3.6 times 10 to the third, is greater than 3.6. So this means we move the decimal point 3 places. So you're going to do the exponent times. So the exponent is 3, so you move it 3 places to the right. Okay? All right, so that's number 1. So here's the number that's written in scientific notation. This number here is in standard form. All right, let's look at number 2. So number 2, we have 4.36 times 10 to the negative 4. So I have this number that's in scientific notation, and I want to put it in standard form. Now I want you to notice that this time the exponent, negative 4, is negative. So this time the exponent is negative. So this means, so 4.36 times 10 to the negative 4, so this means that this number must be less than the coefficient, than 4.36. That's what that means. So multiplying by negative power of 10 means that this number here has to be less than this coefficient, 4.36. So this means I move the decimal point to the left 4 units. All right, so that's what that means. So I move the decimal point to the left 4 units. So since the exponent is negative, to put this in standard form, I'm going to take 4.36, the decimal point, and move it 4 units to the left. 1, 2, 3, 4. So the decimal point goes here. So we're going to fill in those little low points here. So 0, 0, 0. And so always put a 0 in front of that digit right here. So it'll be 0, so it's going to equal 0 point, and then 1, 2, 3. So 3 other zeros, 4, 3, 6. So that is the number in standard form. So that's our number in standard form. Okay? All right, now using this idea we did earlier here, like remember when we wrote 10 to the third times 1,000? We could do the same thing here. I want you to think about this. Now this is the way I want you to think about it, but if you want to kind of check your work, you could think of it this way as well. So let's look at this. So also consider this. 4.36, so we have 4.36 times 10 to the negative fourth. Well, we learned something about negative exponents. So we know that 10 to the negative 4 is 1 divided by 10 to the fourth. So when we talked about properties of negative exponents. So it becomes 4.36 times 1 divided by 10 to the fourth. We also know that 10 to the fourth, this positive power of 10 is 1 and 4 zeros, 1, 2, 3, 4. So that's 10,000. So this becomes 4.36 times 1 divided by 10,000. We also know that I can write this fraction here, so 1/10,000th, I can write that as a decimal. So 1/10,000th means this. So remember, decimal tenths, hundredths, thousandths, 10,000ths, right? So 1/10,000th means, so 1/10,000 means tenths, hundredths, thousandths, 10,000. So 0.0001. All right, and so then I can take this decimal, replace it here. So 4.36 times 0. And then 3 zeros. So 0 tenths, hundredths, thousandths, 10,000. So 1/10,000th. And so multiplying this out, we would get 0.000436. And you can check this. You have access to a calculator. So you see this right here? Just to show you. I'm going to go ahead and use this one. So 4.36 times 0.0001 equals, and then we get this. See? Which is this right here. All right. Okay, so that was number 2. But remember, this is the approach you want to think of. What does this positive or negative exponent right here do to the decimal point of your coefficient? So we know this. We know that if the exponent is positive, I'm going to move my decimal point to the right. So you move it to the right. If the exponent is negative, you're going to move the decimal point to the left. Okay? All right. And remember, the reason why we move it, if the exponent is positive, we move it to the right, is because you're multiplying it by positive power of 10. So this scientific notation, since the exponent is positive here, this number that I'm circling has to be greater than the coefficient. So you have to move it to the right. Here, since I'm multiplying by negative power of 10, since the exponent's negative, then this number that's written in scientific notation has to be less than this coefficient. And notice this number here is less than 4.36. Let's look at number 3. So number 3, we have 4.75 times 10 to the negative fifth. All right, so let's use our same discussion. So you have this coefficient that's 4.75, and I'm multiplying it by a power of 10. Notice, though, that exponent is negative. So since negative 5, I'm going to write it this way. Since the exponent, negative 5, is negative, then the coefficient, 4.75, oops, let me write it this way. So since the exponent, negative 5, is negative, then 4.75 times 10 to the negative fifth has to be less than the coefficient of 4.75. So this number here has to be less than this coefficient, 4.75. So that means I'm going to take this decimal point to make this number less than the coefficient. I've got to take the decimal point and move it to the left. So since the exponent is negative, I'm going to take the decimal point, move it to the left, 5 units. So we take the decimal point and move it to the left 5 units. All right, so meaning 4.75. So I'm going to take 4.75 and go to the left 5 units. 1, okay, 2, 3, 4, 5. Put a little decimal point here. So we have 1, 2, 3, 4. So I have to put an extra four zeros. And never got to put a 0 in front of that decimal point as a placeholder. So for the ones place. So we have 4.75 times 10 to the negative 5 equals, and then in standard notation, it's 0.000012344 475. All right, so that's number 3. Okay, so those examples, those first 3 examples, were taking a number in scientific notation and putting it in standard form. This is usually not difficult for students because all students do is look at this exponent. If it's positive, you go to the right. If it's negative, you take the decimal point and go to the left, that many units. All right, let's look at the other type of problem that you're going to see with scientific notation. Okay, so the second thing you need to be able to do is to take a number that's in standard form, take a number that in standard notation, put this in standard notation, and you want to write it in scientific notation. So remember though, a number written in scientific notation, oops, let me get that page. A number written in scientific notation, remember the coefficient. The coefficient, this coefficient here, must be between 1 and 10. And remember so the decimal point, there's only one non-zero digit in front of that decimal point. Okay, one non-zero digit in front of that decimal point. So what you need to do is notice that this decimal point here is 0. It cannot be 0. It has to be a number that's 1 up to 9. 1 up to 9. So then that means then is I got to move this decimal point all the way until I get one non-zero digit in front of that decimal point. So say I got to move the decimal point all the way between 4 and 8. Okay? So then we get this. So the decimal point goes here, right? And we go ahead and I should not have written it on it, so let me go ahead and do this. This was the original problem. I'm going to rewrite it over, and then I'm going to put that as my discussion. All right, so this is what we wanted, because our discussion is this. So I got to take this decimal point, move it all the way until there's only one non-zero digit in front of that decimal point. So you see where that arrow is? That's where I'm going to put the decimal point. So then this right here becomes 4.821. And then don't forget, you always got to say times 10. Now let's talk about that exponent. First of all, how many places did I move it to the right? I moved it 1, 2. Look what I'm doing. I'm going to go ahead and rewrite it over again. So I moved it 1, 2, 3, 4, and then 5, right? So 5 places. So I moved it 5 places. So I know that my exponent is going to be 5, but the question is it going to be positive or negative? That's what you got to now ask yourself. Is it a positive 5 or is it a negative 5? If you put a positive 5, remember what that does. So this is a positive power of 10, right? So what that means is that since if you leave it like this, what that means is that this number here that's in scientific notation has to be bigger than 4.81, right? Well, this number here is less than 4.81. See, decimal 0.000481 is less than 4.81, right? So what we have here is not correct. So then that means I got to take this number here, this exponent, and make it negative. So always go through that process of analyzing what you have. So since I moved it to the right, since I had this number that's written in standard notation, and I moved the decimal point to the right, that means that this exponent is negative. And notice that when you go backwards, when you take this number that's in scientific notation and you put it in standard notation, remember what this negative exponent does. So that means that this number here, since the exponent is negative, that means that this number here has to be less than the coefficient, and this is. Okay? So always analyze your exponent when you change a number that's in standard notation to scientific notation. Analyze that exponent to make sure if what you have actually makes sense. So let's do number 2. So number 2, we have 0.00065, right? Okay, same idea. Same idea. So I want to take this number that's in standard notation and I want to put it in scientific notation. Well, this digit here is 0. So that means I got to move the decimal point. Let me write this over. So I have to move the decimal point all the way until there's only one non-zero digit in front of that decimal point. So my decimal point has to be between 6 and 5. So this becomes 6.5 times 10 to a power. Well, now that exponent, our first thought is this. Well, how many places did I move the decimal point? I moved it 1, 2, 3, 4, right? So 4 places. So this is a 4. Now think, all right, am I going to leave it as a positive 4 or is it really a negative 4? Well, if it's a positive 4, then that means what I have here has to be bigger than 6.5, and that's not. This number here is less than 6.5, so that means I got to make it a negative 4. All right? Okay, number 3, suppose we had 45 million. Okay, 45 million. And I want to take this number that is in standard notation and I want to put it in scientific notation. Well, in a whole number, that's a whole number. In a whole number, the decimal point's understood to be at the end, right? And so you see all those zeros? So what I'm going to do if I want to put this number in scientific notation is move it, in this case, to the left until there's only one digit that's not 0 in front of the decimal point. So then this would become, right here, this would become 4.5 times 10 to a power. All right, so let's talk about that power. So how many places did I move this decimal point? 1, 2, 3, 4, 5, 6, 7. So 7 places, right? 7 places. So I'm going to put a 7 here. And the question is, do I keep it as a positive 7 or do I write it as a negative 7? Well, if I keep it as a positive 7, then that means that this number here that's in scientific notation has to be bigger than that coefficient. And it is. 45 million is bigger than 4.5. So what I have here is correct. Okay? Let's look at number 4. Number 4, we have 0.0000845. All right? So again, that's a 0 here. And so that means that if I want to take this number that's in standard notation and put it in scientific notation, I've got to move the decimal point all the way until there's only one digit, non-zero digit, in front of that decimal point. So my decimal point has to be between the 8 and the 4. So this would be 8.45 times 10 to a power. So that exponent is determined by how many places you move that decimal point for the first part that you got to think about. So the decimal points here, so go 1, 2, 3, 4, 5. So 5 places, right? Okay, I'm put a 5 here. But then you got to think, is it going to be a positive 5 or a negative 5? So if this is a positive 5, then that means that this number that's in scientific notation, so that's a positive 5, a positive power of 10, has to be greater than this coefficient. But this number is not. It's less than this coefficient. 0.000845 is less than 8.45, right? So then that means this has to be negative. All right? Okay, so I think that should help you with the first part of this section that talks about scientific notation.